Our next senior design first semester project is sponsored by Texas Instruments, so it's another UTDesign project. It's Wi-Fi interference with RF sensor networks. Murat Turlak is the faculty mentor and works on Key, if I'm pronouncing that right. Mentor. Let's welcome the Wi-Fi interference team. Forward. And if you would, welcome them.
Good afternoon, ladies and gentlemen. We present you the UTDesign TI Smart Grid Project 2, which is a Wi-Fi interference for RF sensor networks. My name is Jun Park. This is Marcos Guevara, Chongwon Gong, Jongwan Park, and Dongyan Kim. Okay, I'm pretty sure some of you own a Macintosh published by the Apple, and I'm sure you have used the Magic Mouse for the Macintosh. Magic Mouse is a wireless mouse in which it is connected via Bluetooth network. And the problem with the Magic Mouse would be it consumes a lot of power. And I assume that you probably had to change the batteries for the Magic Mouse in order to operate the mouse. Therefore, engineers came up with a new network called the Zigbee, in which it consumes less power, costs less, and many users can be accessed at the same time. And in order for the Zigbee to be applied in our daily lives, we already have the Wi-Fi network as well as the Bluetooth network. And if you were to introduce a Zigbee, there will be interference between all three networks that share the same channel. And a primary goal would be to find a suitable channel of the interference that exists between the three networks. But in order to do such a thing, here are the solutions that we came up to solving the issue. Our primary goal, as I've stated, to find a suitable channel, and the approaches that we took is to understand the architecture of the MSP430. MSP430 is basically the board in which the CC2520, which is the antennas for the transmitter and the receiver, that will be implemented into the MSP430 in order to create the Zigbee network. And we also had to go through the details about the channel selection mechanism to choose the best channel with the best Wi-Fi interference. And the engineering work that we went was to run and modify some of the example codes in the MSP430. And while we were researching about this project, we came up with many solutions. The best solution that came to solving the issue for us was the RSSI and the LQI. RSSI stands for the Received Signal Strength Indicator, and the LQI stands for the Link Quality Indicator. RSSI basically it gives us a value, and LQI also gives us a value. Higher the RSSI and the higher the LQI determines that there's a strong strength of the signal in the received channel of the Zigbee network. Also, the LQI tells us how high the quality of the received signal in the channel is. Therefore, whenever we get the values for the RSSI and LQI, we are able to determine which channel has the less interference. The fact that we cannot entirely get rid of the interference, we have to go through all of the channels within the 2.4 gigahertz frequency of the Zigbee network to find the best suitable channel. Therefore, the future goals that we'll be taking into consideration would be get all the experiments that we are dealing with, making codes and implementing on the actual circuit in order to find the best suitable channel for our project. Thank you very much. Any questions?
The RSSI measurement refers to the desired signal, or it's a general RSSI measurement that could also indicate level of interference?
RSSI value could be the signal that is sent from the transmitter to the receiver, so we must, the value that it gives determines, say that we are checking the RSS value of the channel 1, then in the received signal in the channel 1 will indicate the strength of the signal in the channel. So therefore, higher the RSSI value means it's getting a strong signal. Therefore, we will compare each of the channels within the frequency band in order to determine the suitable channel.
So the RSSI level reflects the level of the desired signal, so stronger is better?
entirely rid of the interference, yes, RSI set value receives
But the levels will not differ based on interference unless you're measuring interference.
Right.
So you're referring also to multipath or other problems that you may have, due to which one channel may be weaker than another.
Right. Of course, RSSI and LQI values will decrease according to distance. So the 2.4 frequency band, the bandwidth of the different channels that they exist in the frequency band, the further they are, of course, they might be a less strength. But then the fact that the strength and the quality matters of finding whether there is a better channel with the quality as well as the strength, you choose that specific channel.
And will you be sort of generating the LQI yourself, or is there an existing tool that produces an LQI measure that you will just be using?
Oh no, there is an existing tool. It's a software called the Contiki, which we will, it's a kind of an OS in which we will build our own program in order to run the simulation of the RSSI LQI values.
Thank you very much. Let's congratulate Wi-Fi.